Hey everyone, it's Presley at ActOutGames.com here, and today we're going to be doing another atom video.
That's right.
I don't know.
So we're going to follow up a little bit with the other video and talk a little bit more about shells and orbitals,
Yes.
where electrons live around the nucleus. I'll show you a couple of tricks to how to draw them out and make sure you've got the right number in each shell and in each orbital. A little bit of math to do that. And by the end of this, you should be able to draw the electron shell configuration for any atom on the periodic table. And then we can talk a little bit about, maybe in another video, we'll show how they fit on the periodic table and go into that in more detail. But for now, we'll just cover how to put the electrons, how to draw any atom that you want to draw, as long as you know what its number is, or how many protons are in it. Okay? Ready?
Please don't mind me when I'm coughing. I'm just kind of sick.
Yeah, Presley's still a little sick, so there may be some coughing attacks while we're here.
Like right now.
So, if you'll remember, we talked a little bit about, you have the nucleus, and then you have shells for the electrons that go around the nucleus. And that basically kind of tells you how far the electrons are from the nucleus when you're doing that. And those are just numbered 1, 2, 3, 4. We'll go through 7 for this because that's how many you need to draw everything that's in the periodic table. And then each of the shells is broken up into subshells called orbitals. And there's a certain number of orbitals that you have to deal with in each of those shells. So that's kind of what we're going to talk about. There's a relatively easy way to remember or to figure out how many electrons can be in each shell. There's a formula that is N squared times 2. So N is the number of the shell. And for those of you who don't know or don't remember what squared means, it basically just means... Well, not what squared means.
No, go watch the other video.
It basically means times itself. So Presley, let's do a couple of quick calculations here. So if we do shell 1, that is 1 times 1, because that's what squared means, times 2. So what's 1 times 1? 1 times 2. It's 2. That's right, 2. So the first shell,
coffee noise.
The first shell can hold 2 electrons. So let's do the second one. That would be 2 times 2.
4.
And then times 2 again. So 4.
8.
Times 2. 8. So the second can hold 8. You want to do one more? 3 times 3.
6.
3 times 3.
3 times 3.
Yeah, not plus 3. 3 times 3. 3 threes.
3 threes. 3 3. 3 3. That's funny. So 3 times 2 is the end. What? I don't know what I just said. Sorry, I'm sick and derpy, so 9.
9, right? So 3 times 3 is 9, and times 2, 2 nines. 18, that's right. So the third shell can hold 18 electrons. So if you're going through and you're building one of these out, you can always kind of make sure that it lines up with those calculations. And then the orbitals, which we did before in the last video, you can see that we called those, you remember the names of these?
Spidif.
Spidif. S, P, D, and F. The S can hold 2 electrons, and then after that you just add 4.
6.
So 6 plus 4, 10, plus 4, 14. So that's an easy way to sort of keep track of how many electrons can live in each one of these things that we're going to draw out. So I'm going to show you one more thing that you need to keep in mind when you're drawing these electrons. I'm going to draw this over.
And it's almost Spidif.
What?
Spidif is almost Spidif K.
Yeah. Well, there's a theoretical K. We don't
Yes.
use K yet,
Yeah.
so you don't need to worry about it.
Spidif.
So there, if we draw out the shells, and like I said, we're going to do 7 here. So these are the 7 shells, the first 7 layers that break out from the nucleus. And you can remember, so they all, 1 just has an S, right?
So put S going down the wall.
2 has an S and a P. 3 has an S,
PD.
a P, and a D.
Isn't an SPD something in medical stuff?
I don't know. And then there's an S, a P,
But
a D, and an F. So you just, each layer, each shell gets 1 new orbital. And then once you get to 5, you can just keep these same ones. And like Presley said, there are some theoretical orbitals that go past F, but you don't need them to draw anything that's in the periodic table. So drawing out this little table is going to be really important for how you draw things in the nucleus, or in the atom out from the nucleus, right? So these are the different layers, and these are the different orbitals that exist in those shell layers. So what I'm going to do is I'm going to draw out on this side of the board. I'm going to draw the same thing, but instead of just putting the S here, I'm going to put the 2 boxes where the electrons go, and in the P, put the 6 boxes where those go, so that you can see all the layers mapping out. And then I'll show you how to use this to know where to draw them all, because it's not just perfectly straightforward where you fill up 1, fill up 2, fill up 3, and fill up 4. I'll show you what the differences are here in just a second, but real quick, I want to draw some stuff out, and then we'll come right back.
Yeah.
Okay, so sorry about that. Just wanted to not have you sit there while I drew all this stuff out, but you can see that I drew exactly the same thing that we've got here, right? I just, instead of just putting the S, I put the 2 boxes. S holds 2 electrons. Everywhere there's a P, there's 6. Everywhere there's a D, there's 10. And everywhere there's an F, there's 14 boxes, right? So this will show you how many electrons fit in each space, right? Around the shells. And this is the first shell, second shell. So you can actually imagine, if you want to, our little nucleus is right here. And as you get further from the nucleus, this is how many electrons fit in each shell. Okay? And if you wanted to count these out, you could do what we did before with the n squared times 2 and make sure that the same number of boxes exist there. But they do, I promise. Okay? Make sense?
Yes.
You with me?
Yes.
Okay, cool. So now we're going to use this little thing here that I drew that kind of gives us a little bit of a trick. Let me break this. Presley, back up just a little bit so we can see where that's at. So again, these are the different shells, and these are the orbitals that exist there. And what you do is you draw a diagonal line coming in like this. So you start at the top, and the first thing you pass is 1s. So that means 1s fills up first. So your first 2 electrons go right there. 1 and 2 go in 1s, right? And then you draw another diagonal line, and it hits 2s. So that's the next one that you're going to come to. So 3 and 4 go in 2s. And then your next diagonal line, the first thing it comes to is 2p. So you fill up 2p, 5, 6, 7, 8, 9, 10. And then if you keep going on the diagonal, you hit 3s. And so that makes 3s is 11, 12. Now you've done that line. So your next line is 3p, 13, 14, 15, 16, 17, 18. And this is where it gets a little more interesting, because if you keep going, you hit 4s. So instead of going out here, 19 and 20 go right here, right? So instead of filling it out, this is why we talked about in the very first video we did on the atom, that the S and P are the most important ones. Everything wants to have 8 in its outer layer. So once it gets 8 in its outer layer, it's pretty happy. And so it jumps to the next layer and starts going to the S there. So again, next line, see that goes to 3D. So now you come back up here and catch these. 5, 26, 7, 28, 29, 30. I know those are hard to read, but and then you come down to 4P. So 31, 32, 33, 34, 35, 36. And what comes next, Presley?
5s.
5s. That's right, because you keep coming. And then, what was that, 35, 36, 37, 38, and so on and so forth. So you can see as you draw these lines through here, you fill up in that order. And you can see as you go through, you kind of start that, you'll have 2 in the outer shell here while you go back and fill this one up. So even though you're adding new electrons, there's still only 2 in the outer shell. And like we talked about before, the outer shell is the most important thing in determining how chemically reactive it is. And so when we talk about how to draw the periodic table and where these things go on the periodic table, all of this will be very important. So this is all just kind of foundational work for understanding how the periodic table works. But if you can understand this and you can draw this, then you'll understand a great deal about what happens in chemistry. This is some of the most important stuff to understand to see how things react, right? We've talked about this a little bit before, how oxygen comes together and how all kinds of things blend together to do things.
And how this doesn't really make sense if you just look at it with a normal human eye.
That's right. Yeah, you have to look at it with a chemist eye, a little bit of some chemistry, right? And so you'll understand how these things map together, and then what you'll be able to do is you can take any period or any atom on the periodic table and say if it's number, 38 on the periodic table, this is what its electron shell will look like. You draw all the way up to 38. And 39, if you loop back up here, so 39 would be in that box. So you'll be able to draw what the shells look like, and most importantly, when you look, you'll find the shell that's the highest number that has electrons in it, and how many electrons are in that shell is the most important thing about how chemically reactive it is. So with just this information and the couple of tricks that I taught you, which is the n squared times 2, or the start with 2 and add 4 to figure out how many electrons live in each orbital, and then this one little table that's pretty simple to draw out and easy to remember, you should be able to draw the periodic table basically from memory or not even from memory, but you should just be able to figure it out and be able to draw the entire periodic table without anybody telling you anything about it. We've got one more thing we need to do, one more lesson that we'll do that shows how this translates to the periodic table and where something is on the periodic table, but just as a hint, there's a column on the periodic table that is for everything that has 2 electrons in its outer shell, and there's all kinds of rows. So number 38 is in the 1, 2, 3, 4, 5th row, and it's the second one over because it's got 2 shells in the periodic table, or in its outside valence shell. So that's the easiest way to be able to tell where something's going to be on the periodic table, and we'll go into that in a lot more detail as soon as we do our next video. What's Reba?
My head is covering up 7 right now.
Mm-hmm. Okay. Anything else you want to add?
No, not really.
Okay.
We've got everything out in this episode.
This all makes sense?
Mm-hmm.
Okay. We'll do some more later. Bye, guys.